vertical train. Blocks connected together being lifted or lowered. Considering 3 blocks, A, B, and C are connected by ropes 1, 2, and 3 as shown. The blocks are being accelerated upwards at 5 meters per second squared. Calculate the tension in all 3 ropes. Alright, so ask yourself, what would you do after just seeing the horizontal train? How would we handle the vertical train? What would you do first? For me, I would like to get the acceleration of the entire system, so I'm going to look at all 3 of these first, get the tension here, get my acceleration for the entire system. Oh, acceleration is given to us, so I would find the tension here. Because if I have this tension, then I can then chop up my system into different pieces to solve for. Here's an alternative way. Free body diagram for A and the Newton's second law equation. So just for block A, we have stuff that makes it go minus stuff holding it back. And we have multiple objects holding it back this time. So what that tells us is we get this equation, right? Let me show you, whoa, not straight lines, please. Freehand. Stuff that makes it go minus stuff that holds it back. So this is FT1 minus FT2 and FT3. This is just a little mathematical proof for you that if we did stuff that makes it go minus stuff that holds it back and you combined these 2 things, you're still subtracting the whole thing. You're still going to distribute this negative to each one of these, which is going to give you this long equation. That's where it came from. Just want to make sure everybody knew. Now for block B, we have tension 2 pulling it up, tension 3, and block 2's weight holding it down. Now, if I were to wonder, where would my students mess up on block 2? I would think you're only looking at the tension and not including the weight of the block itself. Be careful. Every force needs to go on your free body diagram. If you have your forces properly on your free body diagram, creating your equation is going to be a lot easier. Hopefully you can see that. And then there's nothing holding back FT3 except its own weight. Now, if we look at the AB system and Newton's second law equation, we have that. I don't think I have to go into too much detail anymore. I think you're probably getting the gist of it, I hope. If not, please ask for help. Talk to your partners. Get some clarification. And finally, the BC system. No surprises there. And then we have the entire thing where we have only tension pulling up, but then we also have the weight of all 3 of these. Masses are given, so it's no big deal. It's kind of a scary looking equation though, right? There's a lot going on there. That means there's a lot of potential for error. Be careful. Write down each step on a new line. Show all of your steps for these problems. Alright, so it can be easy or difficult depending on what we choose as our system. To find tension 3, we're going to look at the bottom block only, because tension 3 is the only tension that is acting on block 3. So we're just subtracting out the weight, which we already know. We were given the acceleration of the entire system, so that's going to be the acceleration for block C. And then we solve for Ft to be 30. Next, we're going to find Ft2, looking at the BC system. Ft2 minus the weight of B and C equals the combined mass times the acceleration of the entire system, because the internal pieces of the system are moving at the same rate. Plugging in our numbers that we know, we get Ft2 equals 105 newtons. To find Ft1, we can look at the entire 3-block system. Ft1 equals this. Like I said at the beginning of this, I would do it the other way, I would find ft1 first, and then I would break up, maybe I would do ft3 next, and then I would do ft2. Because if I have ft1 pulling up and I have ft3 pulling down, I got a boo-boo. If I have ft3 pulling down, then it makes ft2 a little bit easier to me. Multiple ways to solve this. I don't care how you get there. I care that you get there with the correct answer and units, and you show the steps how you got there. I also care that you don't break any math or physics rules, so keep that in mind. And we end with 150 newtons for ft1. So there you have it. There's the vertical train. We'll do another one of these